In this video, we're going to be finding the area of a triangle where we're not given the base and the height. Instead, we'll be given two sides and an angle. If you want to follow along, the links to the companion worksheet are in the description below. As with the other videos in this playlist, if you use a calculator or a computer, make sure that you are in degree mode because that is the unit that we're going to be measuring all our angles with. So, let's get started. Now, from geometry, we remember that the area formula for a triangle is 1/2 the base times the height. Now, the way this triangle is drawn, we can see that the base is 200. But what about the height? Now, what a lot of people don't realize is that you can always add geometric figures to the lines, to this triangle. So I can draw in this altitude right here. And I can just say, well, there has to be one. I can always draw from this point down a perpendicular, and this is our height. So the question is, how do we find that? Well, since the height makes a right angle, that means that this is a right triangle. So that means that I can say sine of 60 degrees equals the height over 100. So if I were to solve for h, then 100 sine of 60 degrees equals h. So that means for our area, in place of the base, we know that to be 200. In place of the height, that's 100 times sine of 60 degrees. And so using my calculator, I can get an approximation of this. And so our area is approximately 8,660.254. Now for the next one, we're doing the same thing except that it's obtuse. And a lot of people think, well, we can't do this. Well, actually you can, because you can always draw down the height like this, and I can extend the base like this so that it meets at a right angle. And so if this is 124, then this angle right here is the supplement of 124, which is 56 degrees. And so there's our height. And so in this right triangle, sine of 56 degrees equals the height over 15. And so 15 sine of 56 degrees equals the height. Now there's something very interesting that you'll discover later on when you discover sine and cosine as functions. If I type in sine of 56, I get a certain ratio. But if I type in the angle we were given with, guess what? It's actually the same thing. And that's not by accident. And so I can also say sine of 124 times 15 is also our height. So for this triangle, the area is 1/2 the base, which is 20, times the height, which is 15 sine of 124 degrees. And so as a decimal approximation, that's going to be 124.356. Now, the third one is asking us to find the area of this triangle. And here we're given B, angle A, side C. The rest we don't know. Now, if we look back, the other two examples followed a very similar structure. We're given two sides and an angle between them. And how did we calculate the area? Well, 1/2 times 200, that's one side, times 100, that's the other side, times sine of 60. That's the angle between them. Here, we took 1/2 times 20, that's one side, times 15, that's the other side, times sine of the angle between them. And so that pattern shows us that if we want to find the area here, it's going to be 1/2 one side, B, times the other side, C, times sine of the angle between them. And so anytime we have two sides in an angle, we can always use this formula because What this does is this allows us to say that C is the base, and the height is really B times sine of A. So we're not really abandoning the 1/2 base times height formula from geometry. We're just using it to our advantage here by drawing down the altitude. Thanks so much for watching. If you liked the video, give it a thumbs up. For more videos like this, click the subscribe button. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. And remember, the best way to understand something is to do it.